Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see nodal analysis problem. In previous video we have already seen what is the procedure that need to be followed for nodal analysis, and today we're going to see different problems in nodal analysis, and today we will see problems with only current sources and problems with only voltage sources in this particular video, right? And I would recommend you people to go and watch the previous video so that you can understand the procedures very clearly, so that you can able to understand this particular problem very easily, right? So with this we will start this particular video. First we will start with this particular problem where we're going to see nodal analysis with current sources. In previous video we have seen nodal analysis with only voltage sources, and I have given certain rules and procedures, right? Now you're going to follow the same procedures here, but for current sources you can directly write the current, right? If it is voltage sources, what you will do is you will write the expression as V by R, that is we will subtract the voltage sources and we will divide by R. Whereas for current sources, the current source is directly given, so you don't want to calculate V by R equations. You can directly substitute the current values, right? Now I'll just explain you how to write the equation, and then we'll see how the problem is solved, right? So the question already they have given two nodes, right? That is A and B, and if you take two nodes, right, now first thing what you have to do, you have to identify the branches. So I identify this as I1 and this as I2 and this as I3 and this as I4, right? So I found out I1, I2, I3 and I4, right? So now you have to find out the expression for this particular node A. Now I have already given in the procedure, right, whenever there is a current source and if it is towards the node, then you have to use negative sign. So you can see here the current node is towards A, so it is minus 25, right? This branch is over and this branch, so it is plus VA divided by 10. There is no any source here, so you can take it as VA divided by 10, and now you consider this source here, this branch I3 branch, the current source is directly given, so it is moving away, so it will be plus, right? So it will be plus 5, right? And similarly if you consider this particular node, right, we have node A and node B, so it is VA minus VB divided by 5. So this is the expression 1. This is the expression 1, and you can simplify this expression, right? And similarly now what I'm going to do is I'm going to find out the expression for this particular node, right? So if you take this particular node, we can take this as I5, this branch as I5, this branch as I6, this branch as I7, and this branch as I8. So in that case, we know that by using KCL, it is sum of all the nodes, I5 plus I6 plus I7 and I8, right? So if you take this particular node, this particular branch, how can we write? VB minus VA divided by 5, right? This branch. And if you take this branch, you can see this is only current source, and here the current source is approaching towards the node B, so it is minus 5, right? And here again another branch where you will consider only resistor here, so it is VB divided by 2, right? And now if you take this expression, the current source is given, the current source is moving away, so it is plus, so plus 6, that is equal to 0. So this is expression 2, right? So now you simplify this expression 1 and 2, you will get two defined equation, and if you solve those two equations, you will find out VA and VB value, right? But we need to find out the current across each resistor. So to find out the across each resistor, you take this one. After finding out VA, if you substitute the value here, you can able to find out the current across this particular resistor. And similarly, if you want to find out the across this resistor, you can have to substitute VA and VB. And similarly, if you want to find out this particular resistor, then you have to use VB divided by 2. Right? The procedure is same. Only thing is, if the current source is approaching toward the node, it is negative. If it is moving away, then it is positive. So you can see here, whatever I explained, that is what given here, right? So this particular node, right, 25 is approaching that particular node, it's minus 25, and this branch is VA divided by 10. And similarly, if you take this particular branch, it is moving away, so it is plus 5. And similarly, VA minus VB divided by 5. And if you simplify this expression, you get this equation. And similarly, I am writing the equation for B as well. And now you have equation 1 and 2. And if you solve this 1 and 2 using calci or any method you can follow, you obtain the VA value and VB value, right? And to find out the 12, what you will do, right, for this particular resistor, right, for this 2 ohm resistor, you will use VB divided by 2, right, VB divided by 2, this particular resistor, right? And if you take this particular branch 10, you will use this particular resistor, VA divided by 10. And if you find out this particular resistor, then VA divided by VA minus VB, right? So you will substitute this VA minus VB value, and similarly VA value to find out 10 ohm resistor, so that you will find out across 10, 5 and 2 ohm. Same like we did in previous problems, right? So this is the problem for only current sources. Now you see another problem here, voltage sources with multiple resistors. Already we have seen in previous video what we have to do if there is voltage sources. Here we have voltage sources for multiple resistors. Now once again, the same concept I am going to apply. Now I am going to consider this particular node, right? This node, we have two meshes, so there will be only one node. So I am going to consider this node as V1, and now I am going to take this branch as I1, this branch as I2, and this branch as I3, this as I1. Now how to write? You can see this is higher potential and this is also higher potential. So I'll write V1 minus 50 divided by 3. That is how you normally write. But if you take this particular branch, this branch doesn't end here, it is ending here. So there is another 6 here. So it will be plus 6, right? And similarly, if you take this particular branch, it will be just only this particular branch. So it will be V1 divided by 5. And now this branch, if you take, it will be like this. So if you take this particular branch, it will be V1, it is again higher potential here, V1 minus 25 divided by 2. This is what you normally write, but again you have another 8 ohm resistor, so it will be 8. This is how you have to write the expression. You can also add and you can write as 9 and 10 here. And now if you simplify this expression, you can obtain V1, correct? Now you can see here, that is what I explained. V1, I am considering this as V1. So V1 minus 50 divided by 3 plus 6, this resistor, and this branch is V1 divided by 5, and this branch V1 by minus 25, 2 plus 8. And if you solve this expression, you will obtain V1. And if you want to find out the expression for this across this particular resistor, 3, right? Then what you have to do, you have to use this particular expression, V1 minus 50 divided by 3 plus 6, right? So V1 minus 50 divided by 3 plus 6. So you will obtain this particular value. You can neglect the negative signs. Similarly, you need to find out the value across this particular resistor, right? That is 5 ohm resistor. You can able to use this particular value, V1 divided by 5. V1 divided by 5, you can see here, that is V1 with 19.59 divided by 5, you will obtain this particular expression, right? And similarly, if you want to find out the expression for this particular resistor, the same method you can follow, right? This expression, right? This is actually 2, right? So this particular resistor, so it is V1 minus 25 divided by 2 plus 8, this particular expression, right? So you will obtain this particular value. You can neglect the negative signs. The question is, they have also asked voltage across the 5 ohm resistor. Voltage across this 5 ohm resistor, that is very simple, right? We have already find it out what is the current value, and we know the resistor value. So V is equal to IR. If you use the formula, you will be able to find out this particular voltage, right? So today what we have seen is, we have seen another important topic in the particular subject, electrical and electronics, and we have seen problem for nodal analysis with only current sources and with voltage sources with multiple resistors. I believe this video will be useful for you. Thank you, my dear students.